let's start. My today's talk will be about better code quality for data science. Um, I'm also a data scientist, and currently I'm working on recommendation systems for online cinema at MTS, and it's highly related for today's theme. I will be talk about it a little bit later. I'm also a part of organizers team of mlrepa, and we are happy to make this conference for you. Um, we hope it will be every year. If you want to contact me after this speech, you can write to my email or in Slack in Open Data Science community. So, as for the theme of my talk, making data science models is considered from several parts. The first one is research, and it will be not covered in the speech, and also as the production theme, monitoring of your working models in production. I will be covering the stage that is between research and production, where you testing your code and also you're making code review. Um, in English-speaking companies, sometimes profession of data scientist is split into data scientist itself and machine learning engineer. Data scientist is doing mostly research, and the engineer is writing production ready code, making architecture for your model, and so on. But in our company, when we are making a recommendation system, we have only a data scientist, and we are forced to do ML engineer work also. And it's related to the stages that I will be covering today: testing and development, linters, and I also will show you demo usage for linters in Git using CI/CD. So let me go to quick wins, which you can use in practice during your development stage. First is related to code review. It is highly important to allocate time for this task. If you will not do this, you will, in many cases, you will fail to do code review, and this is difficult to do this while you are run out of time during your everyday tasks. Second part, which we find very useful, is about naming. When we were starting our shared repository, we each of us was doing naming like he was fond of. But when we find out that it's very important to standardize naming, for example, according to PEP 8 standard, and naming should reflect usage or your function and your class. That's how it appears to be a sort of documentation when you are writing a lot of code. Also, it is very important to do a little bit of documentation. For example, a doc string. It should contain of several parts, small description, parameters, and usage example, which is very useful for our specialists like data analytics who may use your code on the same project. These things we found also very useful. We found useful to make very small commits because it saves us a huge amount of time during our code review. It's a lot easier to check small small bit of code, and also using demonstration IPython notebook. It also helps you to understand work of your colleague, read it fast, understand, and check. And we also find very useful to make our code review a lot faster when we started using tests and linters. We are using CI/CD pipeline when we are creating merge request at GitLab. We write comments for the code inside this merge request. When for every push in merge request starts in CI/CD pipeline, which runs automatically tests and linters, which helps us to divide easy checks like p-paid and logical checks, which are made by data scientists. And it helps a lot to speed a lot code review process and make the work in total more confident in result. This is example of merge request in GitLab, which shows how to use it for code review. You just click on the line of code which you want to comment, and then you write your comment. Also, everybody can answer to this comment, and then you change this line of code, and it also appears near this comment. And this is example of how it looks at GitLab. Then you are running a pipeline and it runs successfully. It shows that you have two stages. First is for linter and second for testing. It runs two jobs, each job for each stage, and it runs 5 tests. This is example of GitLab pipeline. Why we decided to use tests? Our motivation was to write code better, and as we are not having a background in developing code, we are all just data scientists. We use it as a tool to write our code simpler, because then you are writing hard to understand function. It will be also hard to test function. When you are rewriting it to fit into tests, it becomes simpler. As it became simpler, it started to be more readable and containing less errors. Also, we have some data quality checks and scripts for monitoring, but they are hard to run inside GitLab CI/CD. So I will not be covering these checks. We also, I'm working at big data MTS, and we have a lot of data. That's why we use a lot of Spark. And we also use Spark functions, Spark classes, which are processing a lot of data. That's why we are using tests on Spark. This is example of how we schematically using it. We are starting a PySpark session, which has scope session, which means that it is available for the whole testing session, and it is becoming a PyTest fixture. Fixture is a sort of variable which contains some information. For example, Spark session. When we are running a lot of tests, each test runs using this exactly Spark session. We are creating pandas data frame, and we are converting it to Spark using Spark filters, converting it backwards, and checking the results using Spark. So it's very easy life hack to use your tests on Spark. And now we are moving to the second part, which helps you to write better code. And these are linters. There are two types of linters. One is auto-formatting linters. The main example is black. It just auto-formats your code. It is it's set up on the Facebook code base, has nice parameters, but it's not appropriate for everyday use, as you may miss some sort of checks, or just too easy way to use linters. You need to read your code better. Second type of linters is linters which provide you a lot of analytics. There are two main types in Python. One is pylint and second is flake8. We are using flake8 as it fits our needs better according to having a lot of plugins. And we are also using one plugin which helps us a lot. And you may also write your own plugin to incorporate your own rules into this linter. Flake8 contains of three libraries. One checks style, one checks common Python issues, and one checks code complexibility. That's why when you're using this library, it runs all these checks on your code, including complexity, which you may find very useful. Next stage, we found out that there is a nice plugin on the top of flake8 called WemakePython, and it says that is the strictest and most opinionated Python linter ever. And we must agree it have a lot of stars on GitHub and a lot of additional checks. For example, it checks a lot of best practices for Python, additional practices, for example, using of f-strings. It checks some anti-patterns for Python, checks some complicated naming issues. And then you are looking at this table, you may compare several linters and may see that WemakePython makes a lot of things, and it's also as easy to run as running flake8. You just type different library, but the syntax is almost the same. But it is having one beneficial part. So When you are using linters on a project, it might be useful to create config file for linter to share it within your Git repository. For example, we are using config in PyProject toml file, and you may write rules which you would like to add, which are written as plus, and you may discard some rules, writing it with minus. And then you just comment which rules are turned off in the same file. It became easy to read, and you can share it with your colleagues, and you will all be having the same setup for the linter. There are um, there are code quality feature in GitLab, uh, mm, but it's a little bit hard to use. Uh, but then you are having your pipeline failed. You may also run the same linter with same parameters in your command line, and the output will be looking better. On screenshot, you may see the main problem of incorporating linter in your legacy project. In your legacy code, there are a lot of errors which are very hard to fix. For example, 3,000 errors for medium-sized project, and it will take you a huge amount of time to check. That's why a lot of people don't use linter on legacy. But the library that we've chosen, it helps. It has a nice feature. It is possible to make your legacy code is not checkable. You just add it as a baseline. Library creates baseline file, and then linter will check only the code which is new, and it will be easy to incorporate one step by step, fixing some problems, and then it will not take you a lot of time to starting using linter. And now I will move on to demo. I will also show example of how we organize our project and why we decided to use CI/CD exactly in recommender system. Here is the example notebook. I hope it will be um, huge enough to see. We have standard imports. When we have some example data, which I'll show right now, we have some watch table. For example, we have table for user, item, and watch length. For example, for Lord of Rings, Harry Potter, and Avatar. We have item features with movie ratings, and we have user features. And we have very, very simple recommender system, which only sorts this content by popularity and chooses the most popular item. Mm. Wait a second. Now we are continuing our demonstration. We are working at GitLab, and that's example of recommending function. It has small description, description for parameters, and it only groups items by length of watch, and then locating the n top popular item and returns it. But specific for recommender systems, that we have a huge amount of pre and post processing. We have a lot of features for movies and for Oscars, for example, for user ratings, for year of starting this movie in the cinema, and we have to write ourselves a huge amount of code to filter, to test, and as we are not developers, where data makes some small difficulties, and that's why we write a lot of code, and we need to test it well. We need to do a lot of code review, and as we started our code review, we find out it takes us a lot of time, and when we incorporated CI/CD into our work, it became a little bit faster. Here is example of transformer, which can filter movies with some rating, for example, plus 18. We write it in the form of transformer, Escalon transformer. And when we are using it, we can combine a lot of transformers, and it also became more readable, but we need to test every one, each of them. Here's the example for filtering plus 18. We do not have plus 18 films. When we are filtering plus 16, we have two fields for plus 16, Avatar and Lord of Rings. We run pipeline with plus 16. Here we have it's not good to do not feed your comments with your code. So we filter plus 12. And then we have a different result for our recommender system. Now we'd like to check it. We are using FlagHell. It is plugin on the top of WemakePython, on the top of Flag 8 library. Wait a minute. I need to turn on virtual environment. Here's help for this library. It's very easy, just small amount of commands. We are mostly using lint when you are writing like hello lint. It will lint all your code in source. You may specify folder or file to check some mistakes just in one file. It shows you line by line its errors. And then it collects a lot of information grouped by the errors. But as I said, there is a problem with legacy code. So you need to make baseline file using this command. And you also need to turn off your config file. Just a second. Here we have config by project Toml, in which, as I showed, we write rules, which we turn on and turn off. We write maximum length on of a line. We make type grouped, and we turn on baseline. We run --config by project on. Hope it work. Yeah, and we have 0 errors in result. Magic. As for CI/CD, for starting CI/CD, we need to create file GitLab CI YAML and git add it to repository and push. Here how it looks like. We have several stages. We have Docker, in which we pip installed requirements, have some tags, and this is the rule for running Flake8. It runs Flake8 for every merge request with parameter config by project home, benchmarking, and output in the format of GitLab. You just create this file, push it to repository, and use it. Example. For example, we can create a branch in our repository. We're creating branch mlrepa, git pull. When we are checkouting to this branch, making some test file. For example, model.txt, model.py. Adding it. We are also making merge request. Creating new merge request from this branch to master. Submitting it. And we are committing this file.
Julia, it seems that you didn't check out to mlrepa branch. You are still in master.
Git branch. Yeah. There was a problem. Git checkout.
Here you don't have minus before B. Checkout minus B.
Yeah. Mistype.
Yes.
Funny. Let's try again. The problem with live coding is it is hard to do live coding. Yeah, here we are. We see then we added this GitLab YAML, added PyProject DOM, and made merge request to our merge request. We have one failed pipeline for it, maybe two. And here we can check maybe some mistypes. But it should work like this. Then you appropriately set up your pipeline. It runs in this this folder in GitLab, and you may use it for checking your errors by linter. I hope that's it for my demo. And to sum up, when you are writing a lot of code, you need to structure it very well. When you are having several data scientists working on one project and one code, it is highly recommended to do code review. Code review without using any additional libraries or tricks may take a lot of time, but you may make it as simple as possible using linters and testing, which will help you to do more code reviews, write better code when you are working on your data science project. And Also, using plugins is an easy win for your project. You may use it to speed up your work a lot. And it is also profitable to share your nice, clean, and structured code with other specialists like ETL and analytics. And it will benefit your whole project a lot. That's all I wanted to talk about today for doing better code for data science. And I will be glad to answer your questions.